Great, we've got the music off there now. Thanks for that. Reminds me of my daughters, the kind of music they like listening to and all that sort of stuff. But I won't be doing any dancing and any singing, although there'll be a bit of dancing and singing about EVS today. So I'm here to talk to you about Amazon Elastic VMware Service, a newly released service to our portfolio. We have around 200 services at AWS. And just a broad poll, anybody in the room, either yourselves or part of your organization, who use any Amazon services at the moment? That's around sort of 60% of the audience here, so that's great to know. So I'm here to focus on Amazon EVS. So let me introduce myself. So I'm Martyn Storey. I'm the head of EMEA Solution Architecture for our specialist solution architecture team, and we focus on migration and modernization. One part of our portfolio now includes Amazon EVS. I used to work at VMware, and one of the roles that I did when I joined AWS was to develop and build the VMware Cloud on AWS business. Is anybody aware of the VMware Cloud and AWS business? I think most of you are. A few nods around the table there. VMC is still there. You can purchase VMC through Broadcom. It's still a service that sits on our EC2 bare metal. But EVS is a fully owned, maintained, and managed and engineered solution by AWS. So let's dive a little bit deeper into EVS. And by all means, ask me any questions at the end of the session and come to the booth and you can have some more detail on stuff. So here we go. So let's just talk about the stack. So as I said, my team focuses on migration and modernization. If you think about migration, so from a VMware environment, if you're moving your VMware workloads to a hyperscaler, to whatever, that's a lift and shift. A lift and shift over from on-prem VMware to EVS is what we call relocate. Anybody heard about the 7 Rs? Relocate, replatform, refactor, rehost. So EVS is a direct lift. You're not changing anything, right? Your on-prem VMware environment will run on EVS directly moved over to an EVS environment. EC2 has been around for a long time. We've been migrating VMware virtual machines to EC2 since 2008. We've got millions of virtual machines globally. EC2 is a very, very large service here in AWS. You have containers as well, so if you're going to refactor your monolithic application, web, or database environment, containers are obviously placed around the application tier. So we have a very large business around something called EKS and ECS, Elastic Kubernetes Service and Elastic Container Services. And then further up the stack, we have managed services replatforming. So fully managed, for example, if you wanted to move your SQL, Oracle, Postgres, any part of your data stack, we have something called RDS. We have RDS for Oracle, for SQL, for Postgres. We have our own relational database solution called Amazon Aurora. So customers who want to get off SQL or Oracle can move to Aurora. We have other database services. These are all part of the managed portfolio. So as part of your migration from on-prem to consume other services, that's the option. Then right at the top of the stack is serverless. If you want to really refactor your applications from monolithic to a serverless-based architecture, lots of companies in the digital space build all their solutions in a serverless platform. So as you're moving up the stack from EVS up to the top, you've got the options. You're building up, much closer to cloud-native architectures, higher ROI, etc. There's a couple of other things on this slide as well to point out. Alternatives to EVS. We've got a number of customers who move over to Nutanix clusters. So Nutanix runs on AWS. So everybody familiar with Nutanix? I'm sure you've come across them in your life. Another great solution to move potentially from VMware to Nutanix, an option. ROSA is also an option. That's Red Hat OpenShift on AWS as well. Again, another option for customers. And on the far right, we have something called Outpost. So that's basically where a customer wants to run AWS on their data center. So where potentially there is a region is not available in certain areas. So we have a lot of customers in the Middle Eastern region who are very much focused in keeping their data on-prem. You can build an Outpost solution as if it's in a large availability zone in AWS. So that at a high level is the stack. But what we're going to do is we're going to focus on EVS now. We're going to go down, dive deep into EVS and what that is. So the use cases for EVS are pretty straightforward. They always have been this way, and they're the same with VMC. So you obviously can expand your data center. I'm working with lots of customers at the moment who are full to brim to capacity with their VMware infrastructure, and they don't want to build another data center, lease another data center, so they want to expand and do a hybrid view. So I've got a lot of customers who are evacuating their ESX hosts over to AWS, giving them some free rein now to actually build some more stuff on-prem. So expanding your data center is one use case, the hybrid use case. DR as well. So some customers, obviously, if you've got to do DR, you've got to build a secondary environment, you've got to replicate your data, you've got to do some on-site replication, maybe use SRM, maybe use Veeam replication, whatever you want. Disaster recovery is an option for you to use EVS and move and replicate your environment over to EVS if you want to do that. Direct migration. Some customers literally do DC exits. They want to close down their data centers. They don't want to be in that game anymore. They don't want to do any capex of infrastructure and storage and network and compute. That's obviously the data center exit use case. And the final one, we kind of touched on it on the first slide, is it's the start of your modernization journey. You know, we truly understand that moving from monoliths to microservices is something that needs to be taken with care and need to understand, you need to assess and understand. But the true benefits of moving from that monolithic architecture to microservices architecture is the start of your modernization journey. And EVS is one of those stepping stones to cloud native architectures. So they are the EVS use cases. At a very, very high level, I'm going to be diving deep into each of these as we go through. This slide here talks about what does EVS look like. It's fully integrated into the AWS console. It was different with VMC. You had a different console experience. But now, if you're a big AWS user and you say you're consuming EC2 or you're consuming anything else, EVS is in that console. So you go to that console and you build your EVS environment directly into a region. This is what it's made up of. Automated provisioning, you go to the console, you deploy your EVS environment directly in there, you put some facts and features in there, including the VCF license key, and it will build your EVS stack for you. Give it a couple of hours, you've got your cluster built. You've got full administrative access and control to deploy. Your control, it's as if it's on-prem. You've got full access to the hypervisor. If you want to do what you want to do on-prem, you've got that. So it's different for VMC. VMC was very hardened and engineered by Broadcom. You did not have access to the hypervisor. It was fully managed. Bare metal instances are based on a i4i.metal instance. I'll go into depth about what that bare metal instance is. They're dedicated hosts to you. Obviously, with a hyperscaler, when you're deploying instances, you're sharing the compute that other customers are using, but obviously secured in a VPC, and I'll go into depth about that in a sec. But obviously with EVS, you need dedicated hosts because they are ESX hosts, right? So they're dedicated to you. The flexibility in consumption, so you can either buy it on demand, do a 1-year contract or a 3-year contract, depending on what you want from your commercial model. If you want to burst into it and do DR on demand, you can do that. If you just want it for a year to do some stuff, to do your migration and modernization, do it for a year. So lots of flexibility and choice of how you want to do it. Bring your own subscription. So your VCF license is your VCF license that you purchase through Broadcom or through their partners. You bring that to EVS and you deploy it directly onto the TIM. So that's the customer's responsibility to purchase the license. Standard VCF 5.2.1, the full VCF stack with SDDC Manager. And obviously, I've already covered off that it's either customer managed or partner managed. So I'm going to go into a bit more depth about that. Before I do that, this at a very, very high level gives you a view about how this looks with regards to the AWS global infrastructure. We're the biggest hyperscaler in the world, so our global infrastructure has got the most number of regions in the most number of environments with the highest round of availability. If you think about the London zone, for instance, or the Dublin zone, the London zone is backed up by a number of AZs. Anybody know what an AZ is? Anyone want to say what an AZ is? Availability zone, thank you very much. An availability zone is a data center. If you think about a data center, you've got AZ1, AZ2, AZ3, AZ4 in a region, and the London region's made up of a cluster of data centers. So if you think about the AWS global infrastructure, you deploy your EVS environment to an AZ in London, an AZ in Dublin, or whatever. If you want to replicate that to an AZ in another data center, now the gap between AZ1 and AZ2, we don't give the exact locations of that for obvious reasons, but there's a decent distance between AZ1 and AZ2. So from your disaster recovery perspective and how you design it, that is exactly how you'd make it from that perspective. So on-prem connection, we're going into depth about how that is facilitated and how EVS is integrated into the rest of the AWS network. When you are there, if you imagine all your VMware infrastructure is now in EVS, you've got direct connection on the backbone to all those other services. So if you wanted to make use of the data, the analytics, if you want to start doing some migrations to other services, you are on that backbone. So that is now part of the use case of it. Your EVS VMware environment is part of that solution, so you take advantage of all the other services. So I just want to sort of dive into the management of it. As I've mentioned, you've got full access to the hypervisor as if you have it on-prem. Obviously, it's our infrastructure, and I'll go into the shared responsibility model on this in a minute. But the beauty about this is we wanted to make the experience as close to what you have on-prem. So fully customer managed or partner managed. We went to during the launch, we had a number of launch partners, of which one of them's Extrovert. You'll see them in the foyer. So they are one of our launch partners. I've got a slide that shows you all the other partners as well in a second. So 2 options for you. You pick and choose what you feel you want to do, and that's what we wanted to do, is have choice, and that's a really, really important point for us on this. So I'm sure a few of you are fairly familiar with AWS, are familiar with the shared responsibility model. So the shared responsibility model is something, part of our major tenets that we've had for many years. The EVS environment, obviously we manage the DC, the compute, the storage database, the actual physical infrastructure, the IAM. So the IAM is the security federated infrastructure we have for getting access to your AWS account. All that stuff at the bottom is what we manage. If it's a managed by customer solution, all the stuff above is managed by the customer or by the partner if it's partner managed. So again, mirroring, I'm sure, what you probably already do on-prem. So your full VCF stack, compute, vSAN, NSX management, it's your decision which part. You may want to choose certain components of that to be managed by a partner, or you may want to just fully manage it yourself. So we take the tack around the shared responsibility model, your choice to choose which parts you want to manage or not. I said I'd bring up the slide about the partners. See, these are the EVS go-to-market partners that we launched with when we GA'd. So some well-known names in there, an Extrovert who are obviously in the foyer out there. I also wanted to show the ISV vendors that we do support as well, and I'll talk a bit about this in a bit more depth in a couple of other slides. NetApp. Anybody in the room using on-prem NetApp for their storage? Brilliant, fantastic. So we fully support, if you may or may not be aware, you can run NetApp solutions on AWS. So effectively you're running something called Amazon FSx. We have a suite of storage solutions. One of them is a collaboration we did many years ago with NetApp, which is called Amazon FSx for NetApp ONTAP. It's a really cool solution for DR, for an organization that's already familiar with a NetApp. So NetApp is fully supported with EVS. We also support Pure Storage in the same way. So NFS iSCSI, NFS, those 2 network storage solutions are available. And Veeam also, they recently released that their backup disaster recovery replication, ransomware solutions are all fully supported with EVS as well. So you'll start to see more ISV vendors be fully supported on the EVS. But at the end of the day, if you've got something that's running that you manage, you've got full access to the hypervisor. So if you're using other components like Zerto, for instance, for doing DR, that's fully supported in EVS as well. So there's the partner landscape. So let's sort of dive a little bit deeper, get a bit more into the tech now for the building blocks of EVS. So as I mentioned, it's the full VCF stack. It supports 5.2.1. VCF 9 is on the roadmap. Can't tell you when it is, but it's on the roadmap. We've already got engineering playing with it, looking at it, testing it. But right now, at the box, 5.2.1. You'll expect to see VCF 9 next year. And obviously, all of that out of the box, vSphere, vSAN, NSX, is pre-configured, automatically deployed through our scripted mechanism, through the console, directly down to the bare metal tin in EVS. So at a high level, that's what the VCF stack is made of, and obviously ARIA is part of that suite. We've got a number of solutions that we're going to be going to market with at reInvent. Our reInvent is our annual conference in Vegas, so we're going to have a focus track on EVS. One of the things that we're going to be launching at reInvent, just to give you some early insights to it, is our cloud operations integration with ARIA. So if you think about ARIA as a great solution, a big fan of Realize operations and automation, obviously part of the ARIA suite. But obviously in AWS, we have a very large business called CloudWatch. CloudWatch looks at every single component that you manage in your AWS infrastructure. We want to integrate ARIA into CloudWatch, so you'll see some announcements on that. I've got one of my team who's building that at the moment. So ARIA is also part of this. So let's go into the compute. So i4i.metal. Now, we chose i4i.metal as the sweet spot of the compute element for the cluster. We use and still use i4i.metal in VMC. So we were very much used to i4i.metal. It's a big box. It can run a lot of virtual machines, right? So 64 cores, 1 terabyte of memory, 30 terabytes of Nitro SSD disk, using Intel's Xeon Ice Lake, 128 vCPUs. It is a great box. Twin 75 gigabyte network cards that go in there are Nitro network cards. It is the sweet spot, and we've been very happy with that so far. Now, if you think about the server fleet, the AWS server fleet, there's approximately 26 x86, Intel x86 servers in the fleet. There are some AMD servers in there as well. And we have a roadmap of different servers that are going to be certified very soon. Obviously, we've worked with Broadcom VMware to integrate that into the HCL. And we've got different type size servers, some with less CPUs, some with more memory, some with less internal storage, because if you think about, for example, the M7i, if anybody's familiar with that, that's basically a headless server with very little internal storage who want to use NetApp as the external storage. So again, giving customers choice. I expect the entire x86 AWS fleet to be certified, but we went to market with i4i in the first one. Clusters. So the maximum cluster size for a VCF cluster is, anyone want to tell me? vQuiz? 64, thank you very much. I did know that, by the way. I wasn't asking to just find out what the answer is. It's definitely 64. So 64 physical nodes in a single cluster. We went GA last August the 5th, we went GA. We started off with 16. We didn't want to upscale right to 64 out of the box. We've already tested 64. We're going to be going potentially to 32 pretty soon, and then we may even go straight to 64 very soon, but we wanted to limit it to 16 to start getting it out to market. So you start to build the minimum cluster size of a VCF cluster, which is 4 nodes, dictated by Broadcom, because obviously that's required for the witness node for vSAN. So you've got 4 nodes as a minimum, 16 nodes as a maximum, but as I say, that's going to increase. The single rack there that you can see is called an EVS environment. You could see it as if it was a VMware cluster. And then if you get to the point where you want to go beyond 16, you build a secondary EVS environment and a tertiary EVS environment. So that, from a rack perspective, is what is supported now in GA. Placement of those servers is very key. There's options about where you want to place those servers. Those servers could be across racks, they could be within rack. It's entirely up to how the customer wants to choose that. But from a dedicated perspective, that's how the customer wants it in the rack. Storage. So out of the box, vSAN is supported as the primary mechanism for your network, for your internal VMware storage. Part of the VCF stack. As I said, within each host, you've got 30 terabytes of storage. Multiply that by a minimum of 4, you've got yourself quite a decent amount of internal storage there. So the primary storage for that will be vSAN. However, as I mentioned before, if a customer wants to do NFS, iSCSI, NFS Connect via NetApp ONTAP or third-party network solutions, And that could actually be, we have other FSX solutions called FSX for Windows. That's effectively a Windows SMB file share that's in the EC2 fleet. That could be mounted to EVS as well. But these are our ISV connections to the storage solutions. We're getting a lot of design and sizing solutions on NetApp at the moment. So they're the two options for network storage. If you decided to choose NetApp ONTAP, that's fully managed by AWS because it's a managed service. So you buy a block of storage, you connect it to an EVS environment, that's fully maintained and managed by us. Obviously, the bit on the left-hand side, the vSAN, as I mentioned, that's managed by you. It's vSAN, you've got control of that. You could have that for your core VMs. You may have it for certain internal workloads that you want to run internally, but you may want to offload certain types of storage workloads to NetApp ONTAP. So that's fully managed by us. Networking, this is where it gets really interesting. So the networking challenge for us was one of the reasons why we wanted to get this right. Because what you think about it, right, you've got an NSX construct and an SDDC. That has to translate through our network construct, which is a VPC, a virtual private cloud. So that's our construct. So getting through that and then beyond that to the customer site is something that we needed to be very, very careful about. So let's sort of dive deep into that. So HCX, everybody aware about what HCX is? Hybrid Cloud Extension, that's the migration technology. I think it's absolutely awesome technology that was developed by VMware. Very, very successful. I'll give you a little anecdotal story. When I was in the VMC team, I got a phone call late at night from the Nordic team at the start of the Ukrainian war. The Privat Bank, Privat Bank is like the largest bank in Ukraine, and a number of government agencies wanted to evacuate all their VMware infrastructure out of the country very quickly. They had a roadmap to modernize to EC2 and other constructs, but their hand was forced to get the infrastructure out of the country. So I was called to move it, and HCX facilitated that move out of the Ukraine to Frankfurt, to the nearest region to the Ukraine. So we managed to evacuate, I think it was 6,000 virtual machines. This is all online for you to read. I think it was about 6,000 virtual machines from Privat Bank over to Frankfurt. I believe it was in 3 weeks, which is amazing. HCX was the facilitator for that. We also shipped in some snowball devices to copy all the data from the bank and some of the other government agencies, and then we did the crossover to HCX over to Frankfurt. So great technology. So this is how it works with EVS. No major difference on that. So if you imagine you've got your AWS cloud and it's sitting in a region, you've got your VCF stack in the top square box there. You may have some other VPCs that are running EC2 and different things from AWS. But as you can see, the two are isolated from each other. They would be connected through to something called the TGW, Transit Gateway, which a lot of customers use when they've got a hybrid connection out to their on-prem data centers or to other services within AWS. You've got your on-prem data center over there. The facilitation of that connection is done via Direct Connect Gateway from the customer's AWS account directly to their on-prem data center with a Direct Connect connection or through an IPsec VPN. Once you've established those two connections, you are then ready to establish your connection via HCX. We're doing a number of deployments at the moment where we're moving workloads from Israel to Frankfurt, from Spain to the UK. There's all sorts of different connections. And when you actually see that connection from their data center to our region in a completely different country via HCX through the HCX console, it's a breath of fresh air. I think one of my essays had a challenge the other week with DNS to get a couple of data centers connected, didn't you? But it was DNS, you sorted it out, and before you know it, HCX was connected and they were moving virtual machines across pretty quick. So that's the establishment through Direct Connect or IPsec VPN. Connect HCX together, away you go. Now we're going to dive in deeper into the network constructs that's within EVS. So the VLAN subnets, host management VMs, vMotion, vSAN, NSX uplink, these are VLANs that need to be deployed as part of your EVS automated deployment mechanism. So when you go to the console, you select the region, you select the number of hosts you want, minimum 4, maximum 16. You provide the console with some CIDR ranges for you to build your environment, but once you've done that, it deploys all this for you. It takes about a couple of hours. All of that is required for the management components within EVS, for the VCF stack. Additionally, what's deployed is an NSX Edge T0 router and an EVS T1 router with a firewall connection between the two. All typical logical components as part of the NSX stack, and everything on that side towards the other part is your routed networks that you build for either through NSX or distributed virtual switches for your virtual machines. Everything from the NSX Edge T0 and T1 is all part of the outbound communication out through to your on-prem data center. So now we'll move to the next slide, and this is part of that. So you'll have your EVS environment over there. You've got 4 nodes that you've built. You've got your 2 NSX Edge routers from a HA, high availability perspective. That routes through to what we call a root server. Our root server is part of the EVS service. That's the communication between your EVS networking component and construct to VPC. It does its networking BGP propagation to the VPC root tables through the VPC root server, and that allows it to communicate out through to Direct Connect and onwards, and also potentially to other parts of the AWS infrastructure stack. So that again is deployed automatically as part of the EVS environment. So that's networking. I've got 5 more minutes left now. So let's talk about migration. So I've already talked about HCX. As I say, I absolutely love this tool. It's really, really well developed over time. There's 3 options to migrate your virtual machines. Typically, minimal downtime, HCX bulk migration, what customers do to do large waves of migrations. But there are some customers who want to do zero downtime migrations, want to use vMotion or HCX vMotion and literally move the VM from on-prem to EVS with zero downtime. That's a 1 VM at a time migration, but there may be scenarios where you want zero downtime, and because HCX facilitates that layer 2 extension from your on-prem to EVS, zero IP changes, it's all part of the choices that you have. You also have downtime as well. When you do full cold migration, you may want to do that for certain workloads that you don't care whether there's downtime for them. So I know this is a bit of an eye chart, but what I'm trying to show here is that the choice of what you choose of the migration types, if you get a chance to read the HCS documentation, have a read, it's really a great read. You choose which VMs you want to choose with which type of migration. So we typically find that customers do the majority of it using bulk migration because there's minimal downtime, but it gets them over pretty, really quickly in large bulks. But we do have customers who want to have zero downtime as well. So again, we would do a consult with you to work out what is the options for you. Okay, that is the majority of the EVS bit out of the way. I've got 3 more minutes. Just want to cover off a couple of things. If you did want to move some of your VMware workloads to EC2 and take advantage of that, we use a tool called MGN. MGN is a tool we've had in the organization for years, allowed you to move VMware VMs over to EC2. That is the tool that we use. I'm not going to dive too much deeper into that, but that's the tool we use. We also have a Gen AI migration tool, of course. We have to have a Gen AI migration tool. We have 3 Gen AI migration tools. It's part of what we call the AWS Transform series. So we have a Transform series for mainframe, a Transform series for .NET. So literally we can migrate mainframes to AWS. We can upgrade .NET. So we have AWS Transform for .NET. So we can upgrade .NET to .NET Core to allow you to modernize your .NET. And we also have AWS Transform for VMware. Basically, at a very high level, it has 4 stages. So first thing, when you want to do your migration, you may have an option you want to look at what you got. You want to understand the number of VMs. You want to understand the application landscape. You want to understand the application interdependencies with each other. So there's an inventory discovery. That's all done through a Gen AI chatbot agent that goes out there. You inject it with some data that you've retrieved from your VMware environment. Could be RV tools, could be another inventory tool that you use. Then it does the network conversion, because moving from an NSX network construct to a VPC networking construct, you have to do some change and translation there. So if you wanted to move to EC2, we would map the EC2 network constructs. Then you do your wave planning. Obviously, you may have hundreds, thousands of virtual machines. If you think about those virtual machines, they're all services. You group them together. You migrate them in waves. So the wave planning process is all part of this chatbot process. And then it does the server migration. So all of this is done through a console that allows you to interact with the chatbot, to integrate it in, then allow it to do the migration for you. Very cool stuff. There's a click-through demo there. Go online and have a look at it, and you can see it in live. Final thing I wanted to talk about is our migration acceleration program. We've had the migration, we call it MAP. We've had it for years. It's both a methodology and a funding program. There are 3 phases to it. There's an assessment phase where we'll do a rapid discovery, a TCO report. This is done by our partners. So the partners that were on the list earlier, we fund those migrations and assessments for you. And then there's a mobilize, and then there's a migrate phase. These 3 phases, we can provide potentially a zero-cost migration for VMware, all through our MAP program. The funding that the partners get effectively gets pushed down to the customers. So effectively, we have worked with our partners to produce a zero-cost migration from VMware to AWS. Wanted to leave you with that. Migration competency partners, all those migration partners are badged with something called our competency framework. And what I want to leave you with is a call to action. Number 1, come and visit our VMUG stand if you want to dive a bit deeper. We've got some people around the organization who are here to help you. Number 2, book a solution architecture demo. Come to my team, come to me. We're always happy to show you EVS in action. Assess your VMware environment. We do that for free of charge, as I mentioned, part of the program. We will either do it ourselves or a partner can do it for you. Assess your environment, see what you've got. And finally, utilize the incentive programs. We give a lot of dollars to partners and customers to do zero-cost migrations. So hopefully you've enjoyed that session. I've literally just done my 30 minutes. I'm here to have any conversations with you after, but thanks for your time. Appreciate it.